Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Yale part number AU 5491 LN REX LH 693 497 1802 in a 619 finish. That's a lot of part number. It really isn't. It really isn't a lot of part number. There's not actually very much to this lock. It is. Although it is, of course, a bit different than your standard run-of-the-mill type lock, it's an electrified lock, is what it is, or at least it is capable of electronic or electric functions. I'm going to empty out the contents of the box, and we're going to discover what all these part numbers mean. So, of course, we can't help but notice this wire hanging off of the chassis. That's going to be the 54, that's going to be the 91 portion in here. And what we're dealing with here on this Yale lock is a grade 1 lever, okay? An overview of the Yale locks, the 5400 series, would be appropriate to start with. This is Yale's flagship grade 1 lever cylindrical lock. So the 5400 is going to be used in those instances where you have a requirement of a grade 1 lock with a lever. Grade 1 is 1,000,000 cycles. Very nice. This is our request to exit portion in here, which we're going to get to. So this is both an electrified lock, and it is it has a request to exit feature on it as well. So the 5400 series is designed for industrial, commercial, and institutional use. The 5400 series is indeed the most rugged lock that you're going to have available from Yale. Key construction features would be the freewheeling lever mechanism, wear-resistant chassis plate. So it's going to have a clutch functionality, where when you rotate that, you're not pulling the latch bolt back at all. Heavy grade construction throughout. Yes, very reasonably smooth action on the key. The 5400 also meets ADA compliance requirements, A117, the federal law, in fact. It's not code, it's law that public doors are accessible to all potential users, certainly including the handicapped. They do call it a freewheeling mechanism, as I had just somewhat demonstrated earlier. That hub is not going to retract when we rotate the lever. This is the type of lock that's going to be locked all the time. The point of the matter is it's not rigid. The concept or the logic there is that when there's something rigid, it's more prone to be vandalized. Well, when it freewheels like this, someone will just figure, okay, there's really no reason to continue to try to damage the lock. So freewheeling is what they call their mechanism that would be considered a clutch mechanism. This conforms with ANSI A156.115 in terms of hardware preparation for steel doors and frames, wood doors as well. These 5400 does carry windstorm compliance as well, and has a variety of options in terms of finish, latch bolt and strike combinations, of course, trim. The features of this lock is that it will work easily on doors 1 3/4 to 2 inch thick. It can also be used on 1 3/8 doors by adding a couple of spacers. Spacers can be ordered. They are literally small little discs that'll be 3/16 thick and are going to fit underneath each side of the lock, and will have a small detail to it. You're really not going to notice that at all. It will have a clean sort of margin. The outside of those spacers are the same outside dimension of the rose itself. You can, of course, order the lock to be used on thicker doors, especially 2 1/4. Which it just simply needs to be indicated at the time of order. Freewheeling lever mechanism increases vandal resistance and reduces the amount of maintenance typically required on lock sets with rigid levers. 13 finish options, 3 lever designs, 24 functions, including the electrified, which is the lock we have here. Stainless steel latch bolt provides added strength and wear resistance. 1/2 inch throw is standard. A 3/4 inch latch is also available. And be mindful what the requirements are of your fire door. Your door itself might specify a 3/4 inch latch throw. Depending on the application of that, you might literally need to order a latch bolt that would not be considered standard for this application at all. Unusual, not unusual, but you will run into it, so be mindful of that. Longer thread locking through bolts through the chassis provide greater stability and prevent rotation. So I guess what they're really saying in that regard is, and we'll get to the bolts shortly, they listed in their features, I guess. Lifetime warranty limited. Heavy-duty lever return springs prevent lever sag and provide positive return of lever to horizontal position. That is a good return action on that inside lever, there's no doubt. The outside is not as robust, but I don't feel that you'll have long-term issues with it. You know, a byproduct of having a freewheeling design is back in the old days when the levers would sag, they would partially retract the latch because this hub was coming in every time. Or not returning back to horizontal could prevent a lock from actually relocking correctly as well. So the freewheeling design does, I suppose, help solve that problem because you're not retracting the latch bolt. There are lots of cylinder options as well. This is this part number is also buried in, that reference is also buried in our part number, the 1802, tells us that it is a standard 6-pin cylinder. Okay, this is in this typical Yale, I think this is in the Para keyway, or the E1R. Just their typical standalone type of keyway. No keyway was specified by the client on this. That's what it would be. The Para stands for paracentric. The other options, you can of course get other manufacturers' cylinder compatibility, including small format, through this material as well, and features 3.5 inch diameter roses. Now, as we scroll through the product catalog a little bit further, and there is a link to that below this video, we see the 3 lever designs. AU for Augusta, MO for Monroe, and then PB for Pebble Beach. The Augusta is probably the most common that's out there. But, you know, the Pebble Beach would probably be the second, followed by the Monroe. Get into functions. We're going to skip because this is an electrified lock. We're going to go right to page 8 of the document and see the area where they call out the 5491, the SecureX they call it. Electric locks provide the ability to electrically lock or unlock the outside trim from a remote location. Fail-safe locks are commonly used in steer towers to release upon fire alarm activation, and fail-secure locks are used on perimeter or security doors to allow ingress using access control technology. You know, combination keypads, you know, sensors, things of that nature. Lots of things can make that happen. Now, the 5491 specifically is fail secure. So in its standard state, it's locked. Okay. This is going to be a unit that is locked. And would provide the ability to enter upon receiving power. When the power drops off, the unit is locked again. Power on unlocks outside lever. Inside lever always active. Latch bolt retracted by key when power is off. Freewheeling lever when power is off, when it's locked. So what's going to happen when you receive power? It's going to basically engage the lever so you can retract the latch bolt. That's what's going to happen. That's your electrical connection. This is going to have their ElectroLinks standard connectors that are available. That's how they're equipped. what that means is across other ASA Abloy products that use the electrolinks, you're going to easily connect everything. What that means is you'll be able to connect from the lock using electrolinks cables or connectors, cables equipped with those connectors, run it all the way back to a power supply, and I would imagine the logic is to plug it into a power supply there as well that is equally equipped. So that makes life really easy. You're not twisting wire is the bottom line. The catalog tells us as a standard feature, the electrolinks connectors link power from the incoming source to electrified locking products, including hinges, locks, exit devices, magnetic holders, and strikes. The electrical specifications: continuous duty solenoid, 150 milliamps at 24 volts DC, 300 milliamps at 12 volts DC. As the volts go up, the amperage goes down. The request to exit switch rating is 3 amps at 125 VC, 2 amps at 24 V DC. They have a fail-safe version of this, which is the 5490. The difference between the two is, what do you want the operation of the lock to be when there's no power, or what are you expecting to have happen in the event of a power outage? If it is a door that is primarily locked all the time, I would think that your options are fail-safe, where you would need to provide power to the lock continuously for it to be locked, or fail secure, where when there's no power to it, it's locked. So I would think that if it was a airport terminal, those doors are going to be locked on the outside all the time until you present your credential. It will close the circuit on the hardware, the electricity will flow, the lock will become unlocked, and then when the power drops off, it relocks itself. I would think that that would be the most appropriate way to go with that, because the thinking is, what happens when in the event of a power outage? What do you want there to be when the power is cut, when it goes out over the weekend? A fail secure lock might be problematic because your door would be unlocked. So there would be instances where fail secure might be more appropriate for your application, but it's more likely that fail safe is the dominating choice in that regard. Now, the previous example that was mentioned earlier was in buildings with more than 3 stories. That's considered a high-rise building. So the requirements on re-entry to floors are quite different in those applications. There have been tragedies that have occurred as a result of the code not being clearly defined, what happens on stair tower doors. So you could have a fail-safe where you are continuously powering the lock so that they're locked. Okay, let's say you've got a 12-story building and you have 4 tenants, 3 floors, 3 floors, 3 floors, 3 floors. You don't want the insurance company going up to the law firm, going up to the architectural firm, going up to the technology firm. So those stair tower doors are going to be locked in the sense that you can't enter the floors. You can always exit and get down and out, of course, is the point. And the inside lever is always active on fail-safe or fail-secure. But in the event of a power outage, or the event, when the power is dropped off, these locks via the power supply will have a wired link to the fire alarm panel. That fire alarm panel, tells the power supply to drop that power. Those locks are going to become unlocked, meaning they're latched, but the levers are now active, which would permit you in a fire alarm condition to be able to enter those floors. That would be typical, providing possibly safe ways in order to be able to exit the building. There was a fire many years ago, 69 West Washington in Chicago, that people could not re-enter the floors and were captured in the stairwells. Code changed right after that, obviously. In the Twin Towers, providing means of egress through stair towers. Everyone below the 80 whatever floor it was, where the strike occurred, everyone survived that was below that floor because they could get down those stairwells. Unrelated, I suppose, to electric lock, but the fact of the matter is that would be an example of fail secure, so that you could re-enter a floor in case there was some sort of a unthinkable reason why you might need to re-enter a floor in an emergency rather than right down the stairwells and out. Okay, so now there is a 5481 version, and there is a subtle difference in the lock that we have. Power, and both of them, power on unlocks outside lever. So when there's power to the lock, you'll be able to the outside lever trim will provide access to the opening. Inside lever is always active. In our 91, latch bolt is retracted by key when the power is off. In the 81, latch bolt retracted either side when power is off. Okay, so that lock is a very pure sort of electric lock in the sense that there's actually no cylinder that operates it. And what they're saying is the latch bolt is retracted by either side when the power is off. The catalog states that the latch bolt retracted by either side when the power is off. I would say that would not be the case. It seems to be like it should state latch bolt retracted by either side when the power is on. Power on unlocks the outside lever. Inside lever is always active. Retracting latch bolt either side when the power is off, it would be a passage at that point. Freewheeling lever when power is off, locked. So the exterior, yeah, it does seem to be odd. When the power is off, it should freewheel on the outside. When there's power applied, you should be able to retract the lever on that 5481. So this lock has a request to exit switch. Request to exit is a REX switch, R-E-X. Operating inside lever triggers REX switch, which can be used to shunt an alarm, monitor egress, release a magnetic lock, etc. So the bottom line is, we mentioned the electrical, electrical profile of the micro switch that is buried inside of here. Hopefully the microphone picked that up. When you rotate that, you can hear the micro switch become engaged. Can't really see much of it there, but it's there. So the bottom line is this. I am indeed curious. They have the locks on this job handed. It is unclear to me that these are truly handed locks. And I did mention earlier about electrolinks plugging into the power supply. I don't believe that that's the case. I believe that you'll have to manually wire your cables back to the power supply, but at least we'll have the connectors. It does not indicate this as necessarily a handed door. Perhaps that'll come into focus in a bit. So on the inside, when you rotate that lever, you're going to, I would imagine, close the circuit on the micro switch. And you would be able to do things with that information. You could report back to a station where someone is monitoring a situation, and they'll get an alarm or something, a light change, an audible sound, that the lever has been rotated. Doesn't mean the latch has been pushed back, doesn't mean the door has been opened. All it means is the lever's been moved. If you think about other ways to bypass a door, you could certainly, if I were to take a crowbar and force the door open and never turn the lever, yeah, well, they're not going to get a signal that the door is open. So you might need to think about, does a request to exit actually solve my problem? I'm thinking that they don't need that control over this door, because otherwise there might be a door position switch or a latch bolt monitoring switch. Probably what they're doing is simply wanting to very likely report back to someone to let someone know that a lever has been turned. Or it could be an annunciator, would be my guess. Other instances of request to exit would be when you have a exit device and you are pairing that with a magnetic lock. When you hit the exit device, you need to be able to have the magnetic lock release. A request to exit can accomplish that. If you are doing exit devices with automatic operators, you get into a scenario that is somewhat reversed, because you'll activate those doors somehow, maybe with a push plate. Well, that push plate can communicate through the automatic operator to tell the exit device, retract the latch bolts, please, and then I'm going to open the door. So that request to exit concept is fulfilled in that scenario as well. Generally, request to exit is going to be seen in a touch bar, where you'll have a horizontal bar on a door, and just touching the bar actually will activate the request to exit, telling the magnetic lock to release. A sensor kind of does that, I suppose, as well. When you enter the space, the sensor picks you up, and it's not a request to exit, but I suppose in a certain sense it may be. So this lock is both electrified and has electrical capability, so people credentialed can enter, and then they're going to know when someone exits as well via the request to exit switch. Moving past the 5491, there is a page that talks about the SecureX accessories. Power supplies really is what they're talking about. There are listed models of compatible power supplies here, Securitron power supplies, that will show you how many locks you can operate based on the size of the power supply. This client has 2 of these locks, so that you can see from that chart that a 1 amp power supply would be adequate. This talked about the milliamperage usage of the characteristics. So it's important to note that you have to figure out the voltage that you're going to be running this lock at. So the rule of thumb is, if we were trying to run 2 of these locks at 12 volts, we've got 600 milliamps, okay? Total potential if you ran them simultaneously. They're saying that a 1 amp power supply is only rated for 1 lock set, and that you need a 3 amp power supply to run up to 3. The way I understand it is, I've heard people say you want to double your potential voltage that you might require. I've also been taught that you're going to add 50%. So I'm thinking 600 possible milliamps, I'm going to add 50%. I'm at 900 milliamps. I'm under an amp. I should be good. There might be a inrush capability with these. I don't believe that would really be the case with a lock at all. Yeah, anyway, following the chart, if you're running these at 12 volt, you need that 3 amp power supply. But you can see where that all comes in. I would probably call, before I bought a 3 amp power supply, I'd call the factory and ask them why I need more than 50% margin, because I'm not going to run these simultaneously, even though it is possible. Now, other items in the part number that we should discuss. The AU is the Augusta. That is this typical lever. The 5491 LN, that's all the function. The request to exit we've talked about. Then we've got left hand or right hand, or you indicate your hand. We've got a 693, and that's going to be a reference to this latch bolt. This is a stainless steel latch, as they had mentioned earlier. This is a beveled latch. Okay, so you're going to specify this for use on a beveled edge door. This is going to work regardless of how your door is going to swing. Okay, the high side of the bevel is always going to be the inside of the door. That's demonstrated here. You ought to be able to tell that that latch face is certainly beveled. If you're doing a flat front door, you're certainly going to want to order the F693. And every trim, every component to the lock should be called out, because what happens when you call it all out is it forces you to consider what are all the different features, what are all the different facets that put this lock together, and it forces you to select the right material. If you've got square-edged hollow metal doors, this latch is not the right latch at all. Okay. The 497, that's our strike. That is our typical culprit. Our 497 is a 4 7/8 ANSI strike, 4 7/8 tall, 1.25 inch wide, typical cylindrical lock. The 1802 is a reference to the cylinder. 1802 tells us that it is a standard 6-pin cylinder, and you will get the para or the E1R keyway for that cylinder. Okay. Can definitely retract that latch in either direction. Okay, now there are installation instructions that are included with this, and let's take a look at those now. Now there is a link below this video talking about the electrified wiring and request to exit instructions, and it is a really simple document. Page 1 just basically shows an overview of how to wire the unit, whether or not you have an Electrolinks prepped door. So if you've got the raceway and the cable running through with connectors, then you're going to go with the instructions on the left. It's just connecting two connectors. I'll leave that to you to review. Page 2 is worth talking about in two instances. Option A. When you study option A, it basically is showing you on the left side, that's your power supply. You've got a couple of wires running to ultimately what's the connector. Okay, and here is the connector, this 8-pin connector. This is the inside. Well, the 2-pin is going to connect to the exterior 2-pin. Okay, so you're going to connect those together. This is going to go to the connector. The 8-pin will go to, towards the hinge. To the power supply. So option A is interesting to look at, because when you look at the power supply, okay, 12 or 24 volt, as you move to the right, normally closed fire alarm contact if required. So it's possible that you're going to have a fire alarm input. Those contacts are normally closed, which means current will flow. In the event of a fire alarm panel, it will open that contact. So it's energized on the fire alarm panel. It probably cuts power to it. I don't know how fire alarm panels work, but power will be dropped off, and that will, of course, interrupt the flow of power is what it does. When you look at the switch or relay contacts, you've got C for common. You've got normally closed or normally open, and that is, this has everything to do with the request to exit switch as well. When you study that, you're looking at a drawing when there's no power, and that's typical. The condition of the switch, whether it's normally open or normally closed, is when you take it out of the box. What does it look like when you're holding it in your hand and nothing's been done? It's not been connected. So we're talking about a switch. You'll have a common line coming to it, and then you can have two options, normally open or normally closed. You can wire it as standard to either of those two. Okay, meaning your switch is going to be by default set to normally closed or set to normally open, meaning that on the application of power, the condition will switch until power is dropped, and then it'll fall back to where it was. So when you were looking at that drawing, we're defaulting at normally closed. That means power is always running. That means when it's powered up. That means in the event of a power loss, that's going to be normally open, which means the circuit will be broken. So that tells me that we're obviously looking at a fail-safe sort of scenario. Okay. So now the lock, of course, doesn't have a switch on it, but when you look at what they're trying to, what they're showing there with a normally closed condition, we are looking at something that is normally closed, which can only be fail safe. If it was normally open, it would be fail secure. The power would be broken. It would be mechanically locked. The bottom line is you'll wire it the opposite way if you're dealing with a fail secure lock. That's part one. Part two that's important to know on the identification of the wires coming off, so that should you need to cut your 8-pin connector, you would know exactly what wires are doing what job. So we've got an 8-pin connector. Only 5 of the connector possibilities are used, 5 of the 8. You've got your red for positive, your black for negative. Then you've got orange, green, and white, and those are defined down below. So it's important to know what those connectors do, and they're defined on the bottom of page 3 as it relates to the request to exit wiring. So the white wire is the normally common, and yellow is normally closed, and green is normally open. So the bottom line is this. You can set this to be normally open or normally closed. When the micro switch is not engaged, it is in a particular state. Okay? Depending on how you're going to wire it, you have to understand which is normally open and which is closed. You're going to use your common regardless. The reason that's important is because you can have, based on normally open or normally closed, a default condition occurring. You might want normally open so that nothing is happening until you activate it. Then the switch is momentarily normally closed, and then a light comes on. Okay? That sort of scenario. Or an annunciator. Or you might want a green light on at all times until it's hit, and then a red light comes on. So you can control that based on how you'll configure your normally open and normally closed wiring. So that is defined there. It needs to be defined so you know what wire does what. You can easily, of course, test that. You could you could power the lock. You could put a small LED light on, well, maybe not an LED, but an annunciator on normally open and common, and then see what happens, and then flip them. So it should always be running in one condition and off in the other. So you'll be able to identify the wires that way. But nonetheless, I don't think there's anything else in the installation instructions really worth talking about. When you're dealing with electrified hardware, you know, it's all but plug and play, is really what it is. And I think the hard part of electrified hardware is putting together more complicated systems where you have multiple pieces of equipment happening and how that all relates to code compliance. There's also a link to the mechanical installation instructions. This lock is incredibly simple to put together. There is not much to it, and they've really, locks have gotten so simple to operate in terms of to assemble. This literally requires 2 screws to put this together. This lock is going to require a modified 161 where you'll have holes at 12 and 6, a 2 3/4 back set with an 1 1/8 by 2 1/4 prep in the edge of the door. Because this is an electrified lock, I won't go into the details of how to install the lock mechanically or how to prep the door. That will be covered in a different video at some point. You do have a template on the back side of those installation instructions, which makes it all super simple. The other link, so we've got the electrified instructions, the mechanical instructions, and we have a product catalog. The product catalog is really handy because that is going to allow you to get to the end of the 5400 series section. Is it the end? Yeah, it is. And it basically tells you what pages to refer to pick out all of the individual elements that you require to safely build a lock for yourself. And that's the part that you go through to not only give the factory the part number you want, understand yourself what you want and how it relates and is compatible with the existing or its sister components that it will work with, but it's also how specifiers will think about how to put together a project, and it is absolutely how detailers will refer to it when they are expressing that information to a factory, is simply the bottom line. So if you have any questions on the Yale 5491 lock or any other Yale product, please feel free to reach out to us. There is a link below this video to the manufacturer's page where you can pull up not only all of the Yale products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. I'm partial to Yale, and it's because I like their products. They have good technical support. Of course, Linus Yale Jr. all but invented the pin tumbler cylinder that we literally use, all of us, on a daily basis. He didn't invent the concept, but he took the original concept that's 4,000 years old from the Egyptians, and he modified it into a pin tumbler cylinder. And the history of tumblers and locks is a very different conversation, but it is Yale, the company, that has direct lineage to the invention of the modern pin tumbler cylinder. Not that that means by Yale, but they have a lineage that is 150 years old for sure. Any questions on this Yale 5491 or any other Yale product, please feel free to reach out to us. And thank you.